Hello everyone, Math Guy here, and today I'm going to be solving another problem from the Stanford Mathematics problem book. It's problem number 59.3, and it's a pretty tough problem, and it's based on number theory, which I love. That's why I decided to post it over here. So the problem says, prove if n is an integer greater than 1, n raised to n minus 1 is divisible by n minus 1 squared. So first off, at first this seems like a problem which you can just solve by using induction, but it's actually a lot more complex than that, and that way doesn't work at all. This is why I came up with this alternate solution, and the first step is, first off, we have to do long division of this polynomial by n minus 1. So how many times is n gonna go into n raised to n minus 1? N raised to n minus 2 times, right? So write that down. That becomes n raised to n minus 1 minus n raised to n minus 2. Change that to a plus. That becomes minus. And you have n raised to n minus 2. Now we have to get to n raised to n minus 2 from just n. So we have to multiply by n raised to n minus 3. And again, same thing happens, and this time we get left with n raised to n minus 3 as the remainder. And this is going to keep on going on and on and on until finally the last term in the quotient will be 1 and the remainder will also be 1. And the reason I can work this out, and this is the reason, so listen very closely. Let's say I end up getting, at some point I end up getting n raised to 1. So basically just n. I'll erase that 1. Okay, so I have n over here, and we have to divide it by n minus 1, right? Because that's the only thing that's left. Everything else we've done. So now I multiply it by 1, and this becomes an n at minus 1. You change the sign, and you're left with a remainder of 1. So now, let's write this in another fashion. Let's say n raised to n minus 1 divided by n minus 1 is equal to n raised to n minus 2 plus n raised to n minus 3 plus n raised to n minus 4 all the way to 1 plus 1 divided by n minus 1. And now, multiplying both sides by n minus 1, we get n raised to n minus 1 is equal to n minus 1 times this whole thing. I'll just call this guy Sn for now, because it's a sum of n plus 1. Okay, so now, the actual thing that we had to evaluate was n raised to n minus 1 minus 1, right? So just shift this 1 to the other side, and it becomes this. And now, since n is an integer, and an integer raised to an integer is also going to be an integer, and you're just adding a bunch of integers over here, this Sn will also be an integer, and n minus 1 is also an integer. So when you divide this by n minus 1, these guys can just cancel off, and you'll get left with Sn. And therefore, n raised to n minus 1 is divisible by n minus 1, which is n raised to n minus 1 divided by n minus 1, a bit of a tongue twister, is equal to some integer k. But we have to find out what happens when we divide by n minus 1 squared. So let's take this a bit step further. So Sn is equal to n raised to n minus 2 plus n raised to n minus 3 plus n raised to n minus 4 and all the way to plus 1. Now let's see what happens when we divide this guy by n minus 1. So we're dividing n raised to n minus 2 by n minus 1. Can you guess what's going to happen? Yes. You get a polynomial which is very similar to what happened when you divided n raised to n minus 1 by n minus 1. So you get n raised to n minus 3 plus n raised to n minus 4 plus n raised to n minus 5 all the way to 1. And again, the remainder that you get when you divide this by n minus 1 is 1. So when you divide each term by n minus 1 over here, each of these terms, when you divide them by n minus 1, you get a remainder of 1. And how many terms are there? Let's see. It starts off with n minus 2, then it becomes n minus 3, n minus 4, and all the way till n minus n, which is basically 0. So it ranges from n minus 2 to n minus n. This means that there's basically n minus 1 terms, yeah? And so now we can say that Sn divided by n minus 1 is equal to some polynomial of degree n minus 3 whose coefficients are integers as well, plus n minus 1 divided by n minus 1. Because remember, the remainder from dividing each of those terms we got was 1. And since there's n minus 1 terms, the whole thing becomes n minus 1. And now, at this point, it just becomes very simple. You multiply both sides by n minus 1 and you get left with n minus 1 times qn minus 3 plus 1. And again, since this guy is an integer and this guy is an integer, you're just going to get another integer again. And when you divide by n minus 1, these two cancel off and you just get left with this part, which is an integer. And therefore, we can conclude that n raised to n minus 1 divided by n minus 1 whole square is some integer k, which is in fact the same as this polynomial, which we don't have to calculate, but if you guys feel up to it, you can do that on your own. Qn minus 3 plus 1. Thank you for watching this video. Have a wonderful day.